Good morning, children. Today I would like to discuss about some assignment questions in 6th class. So the first question for the session is find 5 into 3 on a number line, children. So when you draw a number line, yes, we'll start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and so on. Yes. When you draw a number line over here, they are asking us to find out 5 into 3 by using a number line, children. So either you take 5 as a base number or 3 as a base number. From 0 you need to start. If you take 5 as a base number, 5 steps you need to go. How many times, children? 3 times. Or if you take 3 as a base number, you need to go 3 steps forward direction till you reach 5 times. Okay. So better we will take 5 steps at once. So 1. Okay. Again, this is for step 1. Again, from here, again 5 steps forward direction. 2, and from there you need to take 3 steps. So 3 times. 1, 2, 3. Yes or no? 3 times. So the resultant answer will be 15 for the given question. That is 5 into 3 is nothing but 15. I hope it is clear to everyone, children. Now coming to the second one. Successor and a predecessor of a given numbers. So when you take an integer, a is an integer. If you consider a is an integer, then the successor and the predecessor. So predecessor will be a minus 1. I repeat, predecessor will be a minus 1 immediately before number. Okay, and the successor will be a plus 1. Always remember, a plus 1 is a successor and a minus 1 is a predecessor of a given number, so called a. Now the question is all about find the successor of 11. Successor of 11. What is if 11 is an integer, then the successor will be a plus 1. Yes or no, children? That is 11 plus 1. That is equal to 12. Yes. And the predecessor will be predecessor of 5 they are asking. So it is a minus 1, children. Predecessor is number. So 5 minus 1, that is equal to 4. When you write down on a number line 0, 4 and 12, this 4 is nothing but the predecessor of 5. Yes, predecessor of 5, and this 12 is the successor of what, children? Successor of 11. Yes. Always remember that if a is an integer, then the predecessor will be a minus 1 and the successor will be the immediate next number, that is a plus 1. So if a is an integer, a minus 1 is the predecessor and a plus 1 is the successor of a given number. I hope it is clear, children. Now coming to the third question. The third question of the session, choose the appropriate symbol from either less than or greater symbol. Okay, so the question is all about 8 and 7. Compare these two integers. Next is 5 and 2. Third one 0 and 1. And the fourth one is 10 and 5. So when you compare 8 and 7, obviously 8 is greater than 7. Yes. And 5 and 2, 5 is greater than 7, 0 is less than 1. Why? Because 0 lies towards left side of 1 and obviously 10 is greater than 5. So these are the symbols which we need to indicate. Now coming to the fourth question, children. They have given two whole numbers, 895 and one more whole number is 239. And they are asking which number lies towards right side of the other number. So simply I'll say you one technique, that is, as we all know that 895 and 239, when you compare these two integers over here, obviously 839 is greater than 239. The number which is greater, that lies towards the number which is lesser number. That means 800, and therefore 895 lies towards right side of the other number, that is 239. So when you draw a number line, obviously 0, 239 lies nearer to 0 when you compare 895. Okay. So obviously this 895 lies towards right side of 239. I hope it is clear, children. Now coming to the fifth question. The fifth question is all about, they are asking us to find out whether it is a statement is true or false, children. The first one, all whole numbers are natural numbers. They are saying that whole numbers are natural numbers. No, it is a false statement, children. We can say that all natural numbers are whole numbers, but we cannot say all whole numbers are natural numbers. Why? Because whole numbers are nothing but it is a set of 0, 1, 2, 3, 4 and so on up to infinity. Yes or no? In this, these all 1, 2, 3, 4 up to infinity are said to be called as whole numbers. That means all natural numbers can be said to be called as whole numbers, children. But we cannot say all whole numbers are natural numbers. Why? Because in the natural number we cannot see an integer or a number so called 0 over there. So this is a false statement, children. Now coming to the second one. Second statement, 0 is the smallest whole number. Second statement, 0 is the smallest whole number. Yes, it is true, children. Why? Because in a set of whole numbers, all the counting numbers start with 0, 1, 2, so on up to infinity. Yes or no? 0 is the least whole number. Yes or no? 0 is the least whole number. That means it is true. Now coming to the third statement, children, that is, there is a natural number that has no predecessor. First of all, write down all natural numbers. Natural numbers are nothing but 1, 2, 3, 4, so on up to infinity. All these numbers are natural numbers. Now when you see a number so called 2, the predecessor of 2 is 1. When you take over the number so called 3, the predecessor of 3 is 2. Yes, it is up to now clear. Now they are asking, there is a natural number that has no predecessor. Yes, it is true, children. Why? Because 1 doesn't have any predecessor. 1 doesn't have any predecessor. Yes or no, children? Why? Because 1 is the least natural number and it doesn't have any number which is less than 1. Yes or no? So that means the statement for the third question is true. Okay? Yes, the statement is true. Now coming to the fourth statement, children. The fourth statement, we can show the greatest whole number on the number line. No, we cannot show, children. It is a false statement. When you take a number line, yes, towards positive direction, it is positive integers. Yes or no, children? Towards RHS, we have positive integers, and towards our LHS side, we have negative integers, negative signs over there. Yes or no? So in between 0. So when you write down the numbers, integers over the number line, we cannot, it is undefined. The largest, greatest whole number is undefined. Yes or no? So we cannot define on a number line, so that we can say that it is a false statement, children. The statement so called the greatest whole number on a number line, we can show its sense. No, we cannot show the greatest number on a number line. So the statement is a false statement, children. Yes, I hope it is clear to everyone. So we'll wind up the session with the sum, and we'll come across with a new concept in the tomorrow's session. I hope it is clear. Thank you one and all. Thank you all.